There is an $8 valve inside your engine right now. If it sticks in the wrong position, it will suck oil into a cylinder and snap a connecting rod. No check engine light, no warning code, no strange noise. Just a destroyed engine from a part most mechanics forget even exists. But the more common way it fails is sneakier. Your oil starts disappearing. No puddle, no drips. Mechanic puts it on a lift and cannot find a leak because there is no leak. The oil is being burned inside the engine where nobody can see it. You just keep topping it off every couple weeks wondering where it is going. That is this same $8 valve. And that is just one of 7 cheap overlooked parts quietly killing engines before 100,000 miles. We are counting down from 7 and building to the worst. That $8 valve is number 2, and I will show you exactly how to test yours in 5 seconds. But number 1 on this list is the one that genuinely scares me. A $20 sensor that can be completely dead inside your car right now, and your dashboard will not say a word. There is a class action lawsuit over that one. Hundreds of thousands of cars. So stay with me. Alright, starting at number 7. The crush washer. If you have ever changed your own oil and woke up to a puddle under your car 3 days later, this is probably why. This tiny metal ring sits between your drain plug and the oil pan. When you tighten the plug, the washer crushes flat, and that deformation is what creates the seal. It is designed to crush once. After that, it cannot seal again. Trying to reuse one is like trying to reseal an envelope you already ripped open. Your drain plug is hard steel. Your oil pan on most modern cars is soft aluminum. That washer is the only buffer between them. Without it, steel grinds into aluminum every time you tighten. Do that 3 or 4 oil changes in a row and you strip the threads out of the pan. Now you need a whole new oil pan, over a $1 washer. Not all washers are the same though. Aluminum ones are most common, but forums are loaded with stories about them cracking under compression. Copper is thicker and more forgiving, and you can reuse copper if you anneal it by heating it to a dull red and quenching in water. But the favorite that keeps coming up is the GM metal rubber composite gasket. It seals easily even on damaged surfaces. The Stat-O seal washer with a rubber inner ring bonded to a metal outer ring is another solid choice. Here is something that genuinely made me angry. Even buying from a dealership does not guarantee a real OEM part. One Subaru Forester owner kept leaking no matter what. Bought washers from the local dealer. Still leaking. Drove 50 miles to the dealer where they originally purchased the car. Got washers in genuine Subaru branded packaging. Leak stopped immediately. The local dealer had been selling thinner aftermarket washers in OEM packaging. That tiny thickness difference was the entire problem. Biggest mistake is double stacking. Your old washer gets baked onto the plug by heat and old oil. You cannot even see it, so you throw a new one on top. 2 washers and neither one sealing. Guaranteed leak. Second mistake is not tightening enough because the washer needs to actually crush, but over-tightening is worse. It dents the oil pan surface permanently, and no washer will ever seal on that spot again. Correct torque for most cars is 23 to 30 foot-pounds. For BMW M4's only 18. The crush washer does the sealing, not your arm strength. Get a torque wrench. Sometimes the drain plug is not even the leak. Oil from a valve cover gasket or oil filter housing can run down and pool right at the drain plug. Clean everything with brake cleaner. Let it sit overnight. Then check where the fresh oil is actually coming from. Best upgrade is the Fumoto valve. Replaces your drain plug entirely. No more crush washers ever. Attach a hose and open the valve. People report years of 0 leaks. A crush washer costs $1. A new engine costs thousands. Number 6. This one is a completely different kind of scary because we are going from a slow oil leak to an entire electrical system getting fried overnight. The bill was over $10,000. A 2005 Nissan Titan goes in for a routine alternator and battery swap. Everything works perfectly before the repair. Radio, gauges, power windows, everything. Owner picks it up and every electronic component is dead. All of it fried. Dealership wants $7,000 more on top of $3,500 already paid. Their excuse is that a faulty alternator had been pumping 19 volts before they even touched it. But if everything was working perfectly before they touched the car, how does a pre-existing alternator problem cause damage that only shows up after the repair? That does not add up. Here is what most people get wrong. A bad ground strap does not cause overcharging. It causes undercharging. A corroded ground connection adds resistance. The alternator cannot push full current through so voltage drops. Lights flicker. Gauges act weird. What actually causes overcharging and fries electronics is a failed voltage regulator stuck wide open. That sends unregulated voltage straight through everything. Bad ground means low voltage. Bad regulator means high voltage. Mix those up and you chase the wrong problem for months. The fix is almost embarrassing. Clean the ground connections. Sand or wire brush them until you see shiny bare metal. Bolt everything tight. 5 minutes. Costs nothing. To test it, grab a multimeter set to DC volts. One probe on the engine block, one on the battery negative terminal with the engine running, should be close to zero. Anything over half a volt means you have a ground resistance problem. Now number 5 is where things get strange. This sensor works perfectly when your engine is cold, and then just stops working the moment things heat up. You are driving home from work, engine running smooth, then it just shuts off. No sputtering, no hesitation, just silence. You coast to the shoulder, try to restart, nothing. 20 minutes later, it fires right up like nothing happened. Drive a mile, it dies again. That is the crankshaft position sensor failing from heat. A 1990 Cutlass Supreme with only 36,000 miles did the exact same thing. Cold engine works, hot engine dies. Wait for it to cool down, and it fixes itself. Now try explaining that to a mechanic who tests the car after it has been sitting in his shop for an hour. He finds nothing wrong, because at that moment, nothing is wrong. Inside the sensor is a magnet. When it gets too hot, the magnet loses strength. It hits a threshold and the signal drops off a cliff. No signal means no spark and no fuel. Engine dies. One forum user proved this perfectly. Heat gun on the sensor. Engine died. Compressed air to cool it. Engine restarted. Cleanest diagnostic you will ever see. OEM sensors use plastic casings that insulate from engine heat. Cheap aftermarket CKP sensors use all metal housings that conduct heat directly into the magnet. One owner said their aftermarket metal sensor failed from heat in weeks, while the factory plastic one lasted years. On this part, do not go cheap. OEM, or a quality brand like Napa, even if it costs $100. But sometimes the sensor is not the problem. A VW Polo owner replaced theirs, fixed for 1 week, same failure. Actual problem was the reluctor ring with worn teeth. Heat expansion changed the air gap just enough to kill the signal. A scan tool cannot catch that. You need an oscilloscope. Another owner dropped $800 on a sensor replacement and had the same failure 6 months later at highway speed. Root cause was chafed wiring in the harness. Crankshaft position sensor was fine the whole time. Always check wiring before you spend money on a new sensor. And on some engines like the 2002 Accord V6, the sensor is buried behind the timing belt. If any of this is saving you from an expensive mistake, share this with someone who works on their own car. It could save them thousands. Number 4. This one does the opposite damage. Instead of shutting your engine off, it keeps it running in a way that slowly destroys it from the inside. And your dashboard might tell you everything is normal the entire time. The engine coolant temperature sensor, about $20. When it fails, it gets stuck reading cold. Computer thinks the engine is freezing and dumps in extra fuel. That extra fuel washes oil off the cylinder walls, dilutes your engine oil, overwhelms the catalytic converter, fouls spark plugs. Meanwhile, your temperature gauge says everything is fine. But here is the trap. A lot of cars have 2 completely separate temperature sensors. One talks to the engine computer, the other talks to your dashboard gauge. Completely independent systems. Your gauge can show normal while the computer sensor is totally failed and the engine is running dangerously rich. I have personally seen mechanics miss this. A 2003 VW Jetta TDI uses a 2-in-1 4-wire sensor where one side feeds the computer and the other feeds the gauge. Gauge side failed. Gauge pegged cold. But the engine ran perfectly because the computer side was fine. That is how separate these circuits are. A Mercedes E320 owner failed emissions for running too rich, had already replaced coils, wires, plugs, intake air temp sensor, mass airflow sensor, oxygen sensor, even the catalytic converter. Still smelled like gas. Finally, someone checked the engine computer temperature sensor. Out of spec. That was the whole problem. Hundreds of dollars in unnecessary parts because nobody checked a $20 sensor. A thermostat stuck open produces almost the same symptoms. Engine never reaches full temperature, so the computer keeps pouring in extra fuel. The difference is that a failed sensor locks the gauge at dead cold with zero movement. A stuck open thermostat lets the gauge rise a little in traffic, but drops back at highway speed because airflow overcools the engine. That pattern tells you which one it is. Quick test. After 15 minutes of running, squeeze the upper and lower radiator hoses. Both hot means the thermostat is opening normally. Upper hot but lower cold means stuck closed, and that is dangerous because coolant is not circulating. That can crack a head gasket. Do not trust your dashboard temperature gauge. Both the sensor and thermostat run $20 to $30 each. Replace them together and skip the guessing game. Now number 3. Your engine has a built-in microphone bolted to the block right now. Its only job is to listen for the sound of the engine destroying itself. When it fails, you lose that safety net completely, and there is a massive scandal behind this one. But this is not the class action I mentioned at the start. That one is still coming. The knock sensor, a piezoelectric device that picks up vibration frequencies from detonation. When it detects knocking, it signals the computer to pull timing back to protect the engine. Without it, the computer is flying blind. A 2001 Lexus LS 430 owner drove almost a year on a failing knock sensor. Computer pulled timing way back, which made the engine run extremely rich. After 6 months, the catalytic converters were almost certainly cooked from all that unburned fuel. Replacing the sensor costs $70. Replacing catalytic converters costs thousands. That is what putting off a repair looks like. Now, the scandal. Hyundai and Kia Theta. Two engines had a manufacturing defect in the connecting rod bearings. Their software fix called Campaign 966 repurposed the knock sensor to listen for bearing noise and trigger limp mode. The problem is the software is absurdly oversensitive. Normal engine noises trip it, low oil trips it, driving through a car wash trips it. Hyundai Kona N owners have it especially bad. Known issue with a technical service bulletin and everything. One owner was denied warranty at 60,000 miles as a third owner. Dealer quoted $1,400. The parts cost $70. That is a 20-to-1 markup driven entirely by labor and dealer policy. Dealerships just clear the code. 20 minutes. Nothing actually solved. Hundreds of thousands of owners affected. Class action lawsuit. Warranty extended to 150,000 miles and it transfers to second owners. If you own one, go to a dealer even if your model is not on the list. People have gotten free replacement engines on vehicles not even named in the lawsuit. A brand new 2023 Volvo XC60 had a factory defective knock sensor within its first 10 kilometers, $60,000 car. Even Mini Cooper had a full production stop sale over a knock sensor batch. It happens at every price point. But the most important lesson from this section comes from a 2003 Toyota Highlander V6. It overheated severely from a water pump failure. After the repair, it threw knock sensor codes for both banks. Owner replaced both sensors and the wiring harness. Codes kept coming back. The answer was in the oil. Metal flakes. The engine was physically knocking from real internal damage. The sensors were working perfectly and detecting actual destruction. If you ever get knock codes after an overheating event, do not throw new sensors at it. Drain the oil and look for metal. Do a compression test. The sensors might be telling you the truth. Number 2. This is the $8 part from the beginning of this video. The valve that makes oil vanish without a trace. The PCV valve. Positive crankcase ventilation. It routes blow-by gases from the crankcase back into the intake manifold to be burned off. $8 to $12 at any parts store. And it fails in two completely opposite ways. Stuck closed and pressure builds up inside the crankcase. That pressure forces oil out through every gasket and seal it can find. Valve cover gaskets. Oil pan gasket. Rear main seal. You keep replacing gaskets, but the leaks keep coming back because the gaskets were never the problem. The pressure is the problem. No check engine light. Engine runs fine. You just keep spending money on gaskets that keep failing. Stuck open, and it is what I described at the start. Engine vacuum pulls oil straight out of the crankcase into the intake where it gets burned. Your oil is not leaking. It is being consumed inside the engine and coming out the tailpipe as faint smoke you might not even notice. Stuck open means oil burned. Stuck closed means oil pushed out. Figure out which one and you know where to look. A 2014 Jeep Wrangler with the 3.6 Pentastar had the most frustrating oil consumption pattern. Sometimes 3,000 miles with zero loss. Then a quart and a half gone in 1,400 miles on a mountain trip. The Pentastar uses a centrifuge-style oil separator with a rubber membrane. Over time, the hole in that membrane gets bigger. Oily air bypasses the centrifuge entirely. Owner replaced the PCV assembly. Oil consumption stopped dead. The old membrane hole was visibly stretched compared to the new one. $8 fix for what every mechanic called a dying engine. Honda Accord owners with the K24 engine see this constantly. One owner was burning a quart every 500 miles, pulled the PCV valve and it failed the rattle test, replaced it. 2,000 miles later, zero oil loss, completely fixed. On the other end, a 2022 Subaru WRX owner was burning a quart every 800 miles, replaced the PCV valve and it worked for a while, but the consumption came back. Root cause turned out to be piston ring tolerances from the factory. So here is the lesson. PCV replacement is always the right first step because it is cheap and often fixes it entirely. But if the consumption returns after a new PCV valve push for a compression test and leak down test, The PCV fix might have been masking a deeper problem. A 2011 Honda CR-Z owner never burned oil in 125,000 miles until one sustained high-speed highway run. Sudden onset after extreme heat. Same root cause. And on the GM Cruise 1.4 Turbo, the PCV check valve sits inside the intake manifold. When it fails, it gets sucked into the engine. Car boosts fine for 10 minutes, then falls flat. Repeat. On turbocharged cars, it gets worse. Under boost, the intake side gets pressurized. The PCV valve is supposed to close, but one forum user tested multiple brand new valves with a compressor and every single one leaked. Your stock PCV on a turbo car is a direct boost leak. The real fix is a brass check valve inline. A catch can does not fix this. A catch can only collect vapor that has already escaped. You need the check valve to stop pressurized air from flowing backwards through the PCV line. For VW and Audi EA888 engines, this failure is so common that one mechanic says he replaces multiple PCV assemblies every single day. If the PCV fails on these engines, crankcase pressure blows the rear main seal. Replacing a rear main seal means pulling the entire transmission. Thousands of dollars. A $55 PCV assembly every 50,000 miles prevents the whole thing. And the Honda K-Series shows the worst case. PCV fails open. Oil gets sucked into the intake. Pools in one cylinder. Piston comes up and tries to compress it. Liquid does not compress. The connecting rod buckles or snaps. Hydrolock. Catastrophic engine failure from an $8 valve nobody checked. 5-second test. Pull the PCV valve out and shake it. Rattles freely, it is probably fine. Silent or stuck, replace it. $8. 5 seconds. Cheapest insurance your engine will ever have. And now number 1, the last one. Honestly, this is the one that has been on my mind the entire time because everything else on this list at least gives you a sign. Oil disappearing, lights flickering, engine dying randomly. Something feels off. This last part gives you nothing. 0 symptoms, 0 clues. And then one day, your engine just seizes. This is the class action I have been telling you about. A 2016 Kia Sedona. Owner is driving normally. Engine seizes. No warning lights ever came on. No weird noises. No performance issues. Just driving one moment and then the engine is gone. Complete oil starvation. A Ford Edge owner had the exact same outcome. Checked the oil and believed everything was normal. Engine locked up solid while driving. No prior warnings of any kind. This is not a one-brand problem. It happens across manufacturers. Why did the oil light never come on? The oil pressure light does not monitor oil level. It monitors oil pressure. Most cars do not even have an oil level sensor, only a pressure switch. And by the time pressure drops enough to trigger that switch, the damage has already started. This is not a warning system. It is a death notification. The pressure switch itself can fail, stuck open. When that happens, the light physically cannot turn on. Even at 0 oil pressure, no trouble code, no scan tool flag. Here is how it plays out. Engine burns a little oil over months. Nobody checks the dipstick because the dashboard shows no warnings. Level drops gradually. As long as there is enough oil for the pump to maintain pressure during normal cruising, the switch reads fine. Then during hard acceleration or going up a hill, the remaining oil sloshes away from the pickup tube. Pump sucks air. Pressure drops instantly. Oil light comes on. But the bearings have already made contact with the crankshaft. Metal on metal. The engine can seize within seconds of that light appearing. That bulb test, when you turn the key where the oil light comes on for a second, that only tests the bulb and wiring, not the sensor. Your pressure switch could be dead right now, and that key on test would still pass. BMW owners have their own version. On N51, N52, N54, and N55 engines, the oil pressure switch can leak oil into its own electrical connector and down through the wiring harness. The computer loses communication with the sensor and silently skips the oil level check. No warning, no fault code. One owner was 2.5 liters low, 38% oil deficit. No idea because the system had been silently failing for months. An Audi 1.8T owner got a red oil pressure warning on the Autobahn at 180 kilometers per hour. Drove 5 more kilometers looking for somewhere safe to stop. Engine started grinding. Root cause was a clogged pickup tube from sludge buildup. Engine survived with a €700 repair. But the damage came from those extra 5 kilometers. That is all the distance between a minor fix and a destroyed engine. If that oil pressure light ever comes on, pull over right there. Not the next exit. Not a gas station. Right there. If you hear knocking or ticking, shut the engine off that second. Do not drive another foot. Call a tow truck. Every second of metal-on-metal contact is doing permanent damage that cannot be undone. One more thing though. Not every seized engine diagnosis is real. A 2015 Mazda 6 owner got told by a mechanic 200 miles from home that the engine was completely seized, but the oil light had never come on. Forums said try turning the engine by hand using a breaker bar on the crankshaft bolt. If it turns, it is not seized. Turned out to be an electrical problem. That second opinion saved thousands. A Dodge Ram 3.7 V6 owner had the gauge drop to 0 at idle, then read normal when accelerating. No knocking, no ticking. Classic failing sending unit, not a failing pump. But a 1972 Chrysler Newport owner drove home on the expressway with the oil light on because the engine sounded fine. He gambled and got lucky. Do not do that. Only way to truly know your oil pressure is a mechanical gauge tapped directly into the oil system. Dashboard gauges go through sending units that can be just as unreliable. A mechanical gauge cannot lie. Here's the bottom line. Check your oil with the dipstick every 2 weeks. The warning system in your car might already be broken, and it will never tell you. Change oil on schedule with the correct viscosity. Old oil turns to sludge and clogs the pickup tube. That is how starvation starts. If the oil pressure light comes on, pull over and shut off the engine immediately. If you hear knocking or ticking, kill the engine. Every second matters. BMW owners, check that oil pressure switch connector for oil contamination even if everything seems normal. Kia and Hyundai owners, check your oil constantly and know your warranty rights. Even if your model is not listed, take it to a dealer anyway. People have gotten full engine replacements on models never officially covered. 7 parts. All under $50. All overlooked. And any one of them can quietly destroy an engine that had years of life left. The most expensive mistake in car ownership is not a part failing. It is assuming no warning means no problem. Check your oil, listen to your engine, and never assume silence means everything is fine. And speaking of parts that fail silently, there is one more that causes most engine misfires and almost nobody tests it until the damage is already done. I made an entire video on that one. It is right here.